Hi folks, I'm Roger from Offgrid Power Solutions, and in this episode we are taking you through the build, sort of end-to-end build of this 24-volt system that also has heating pad built into it. As you will see, well, most of the heating pads, almost all of them in fact, are 12 volts, so it's difficult to get a 24-volt heating pad and the temperature controller as well, all that sort of stuff. So we have a converter to go from 24 to 12 just to run the heating. I've left the wire outside for him to connect to his on the other side of his shunt so that he can count the coulombs used by the heating system to get a more accurate idea of the state of charge. So here it goes, not too heavy. Two of us can carry it easily. One person could carry it, but it's about 50 kilograms, so reasonably heavy.
So we pre-made the sides for this case, so we quite like to take two pieces of ply and glue them together. Usually that's sort of probably 6mm ply, so it gives you a total of about 12mm of ply, and that's what we found to be optimum for this type of battery. So like a 24-volt battery that will weigh around 50 kilos. If you are making a bigger battery, like a 16S battery, you probably need a bit more structure on that, but this gives it a lot of strength and rigidity, and also by gluing two pieces like this together, it gives you a little shelf that you can put other stuff onto.
So for this 8-cell battery, I'm busy deciding just how big I want this board to be. Probably bring it to about here. On this side I've used a bus bar, normal bus bar, just to get the spacing right. That's about the gap that I would want. We're going to have a thread bar running through the middle of this. Obviously there'll be 4 cells stacked here, 4 here, and with the 2 thread bars, one there, and then we'll have thread bars on each side running through there. So just deciding exactly how big I want this. This gives me quite a lot of height here, but I need some things in that space, and it's still plenty of room to fit into the space that they've given us. So that should work well. It's about the size I want, I think. Part of the decision making is around which of the heaters to put in. So the customer wants this to be heated battery, so we're going to build the heating system in, and then he'll build an insulated box using whatever materials that he has. It's a choice between this 50-watt pad. So it's a pretty good pad. I mean, it's quite expensive. The cost price of this is quite high, actually. It's supposed to be very, very good quality. And it can be attached to the cells, but of course if it's sitting in the middle between all the cells, then you wouldn't want to actually attach it. So yeah, it's probably going to sit somewhere in there. There'll be a thread bar, and it's going to need to go on one side or the other of the thread bar. So it's a toss up between this 50 watt or these 3 10 watts. So 30 watts altogether, or a single 50 watt. If I use these, then I'll place one in the middle somewhere and then one on either side, and on either side I could use the stuff to fix it on. The problem there is that you'd only actually directly heat the cells that it's been fixed to, so probably just leave it loose on the side if I use those. I'll be using this, which is a temperature controlled switch, and you can configure it and set it up to what you want. So that's what I'll be doing. It's got a temperature probe that I'll be putting somewhere logical to tell this when to turn the heating pad up. Probably set it to turn on at roughly 6 degrees centigrade, because the BMS will be set to turn charging off when it goes down to 5 or less. So at about 6 it'll start heating up, and that'll probably do the trick. Because it's a 24-volt battery, it's very difficult to get 24-volt heating pads, and I couldn't get them in time for this anyway. So I need to get a 24 to 12 converter. So here's a small one that'll convert 5 amps. This much bigger one will convert to 20 amps. So I mean it's a lot bigger though, it's a lot bulkier, but with cooling pins and everything. But I think given that I only need about 4 amps, 50 watts, I'll probably go with this one rather than the big one.
Next task is to measure out and mark how big we want these ends to be. So we made them bigger than they needed to be so that we could cut them down precisely to the exact size that we want and have the exact right amount of space for the thread bars to go between the cells, etc. So got them onto the planer to clean the edges up after gluing the two pieces of ply together, and then measured out and cut them precisely exactly how we needed them. Made sure that they're square, just so it's accurate, and you get a nice square box. So yeah, just cut everything out nicely. Obviously there'll be a fair amount of cleaning of these ply ends as well, just in terms of the jagged edges, so we'll just sand those down. Next, we used some templates of cells that we have in the workshop to be able to mark out exactly where we wanted everything to be. So this is the step that we always take a bit of time on, just making sure that we've got it exactly right, making sure that the cells will definitely fit, they're not going to rub on the thread bar. So although we put hose over the thread bars, we still want enough space between the thread bars and the cells so that there's no damage to the cells or anything like that. But yeah, we just spent some time marking it all out, measuring everything out, marking where the holes need to be, etc. We've just found that if you take your time on this process, you'll have a much better build and it'll be much more accurate and look much better. Next was to measure out the holes on the top that we'll cut out for the handles. So obviously with this we want to get it precise as well, so get it in the middle and have them evenly on each side.
Right, I've marked everything, checked and triple checked. I'm going to be using these connector nuts, so there'll be 6 of them on each side, 12 altogether, 6 thread bars. So just double checking everything. One cell will go here against this line that I drew. So this is how it'll actually sit. That one lot of cells with the connector bolt. I've left a bit of generous spacing around here just because I can afford to. Didn't need to make it tighter than that. And so I've marked out each of the 6 holes that'll be drilled. So 1, 2, 3, 4, 5, 6. Then at the top, if we can see through all the shadows, I've marked, so I'll be drilling a hole there, and then using a Forstner bit, a much bigger hole, and then cut them out for a handle here and similar there. And obviously on this ledge is where we'll put some bars to screw the BMS and the other electrics into. So looking good.
So you can drill all of these out by hand, but we've just found that it's much more accurate and gives a better finish if we do it with a drill press. So we've got a dedicated drill press that's used just for woodwork for building these cases. So sometimes the drill will get stuck in the ply because obviously you're drilling through quite a bit of ply, and we use pretty good quality marine grade birch ply for these battery cases. So once we've drilled the pilot holes, which are where the connector nuts actually sit inside, we then drill a bit of a recess using a Forstner bit. So the recess is not very much, it's probably only 3 mils, 2 or 3 mils, something like that. Basically enough to just have the top of the connector nut sitting in that. So we just whiz through, drill the recess for all of the holes. We can do all of the outside holes apart from the one inside hole. So just take the Forstner bit out, put it into a handhold drill, and drill that out as well. Once that's done, we then need to start drilling out the holes for the handles. Now for the handles, that's pretty straightforward. We just use a pilot hole in our drill press, as you can see there, and once that's done, we then use a Forstner bit to actually drill all the way through. We quite like using the Forstner bit just because it gives you a perfectly round finish for your handle. So if you cut it well with a jigsaw, you get a really nice neat handle, but it's just the easiest way that we've found to do that in these bits. Cut it really clean. One thing to note though, when you're using a Forstner bit, if you're cutting all the way through your piece of timber, is to have a sacrificial piece underneath it. That just allows you to go all the way through the good piece, and you don't have any damage and weird chips or anything like that on the bottom of it. So next was just to cut the handle out using a jigsaw, and then the trusty old handheld sander, and just sand everything down, clean everything up. And then lastly we just spray it down with some black spray paint just to give it a nice clean finish. And we tend to just do the outside, not the inside, because this is just for aesthetics. Once it's all dry, we then bring it into the workshop and start the assembly process. So that's pretty straightforward. Essentially, we just put the cells out onto the workbench in the position that they are going to be in. We then put the plastic insulation spaces between all of the cells and push the cells together just by hand. Even at this point, we don't tend to put the bus bars on, apart from a couple just in the middle to space those and get those spaced correctly. Obviously, we've spent so much time measuring everything out and making sure that it's all accurate that we're pretty confident that this will work. We then cut the clear hose that we put over the thread bar. So this is some hose that we've found which is the perfect size for an M6 thread bar. It takes a little bit of work to actually get it on, but it's a really snug fit and works really well to insulate your thread bar. It actually is the same diameter as the shank of the connector nuts, so you can actually push it through the holes that we've drilled there. I think those holes were M8, so slightly bigger than we need, obviously, with it being M6 thread bar, but it just makes the assembly process really easy. And obviously, because the connector nuts have a big wide head on them, they tighten up really nicely. So next is just to hand tighten everything up together, and then we'll put some Allen keys onto the connector nuts and tighten them. We tend not to over tighten them or anything. Essentially, we want to just tighten them to the point where it just holds the cells together nicely, and as they expand slightly when they're fully charged, they'll then be really snug in the case. So yeah, looking pretty good, pretty happy with how that's turning out. Just double check things, make sure everything's all right, and then crack on. As you can see, we're not putting a huge amount of torque on this, we're just hand tightening it to the point where it just keeps the cells a little bit snug so that they can't move freely easily, but they should still be able to move slightly.
So the 8 cells are now clamped in the enclosure, except for one of the bars, which I'm leaving till a bit later. Tightened sort of finger tight with the Allen keys. So they are currently at about 30% state of charge. So, and I put these little plastic spacers. So it's this thing here, this yellow plastic. Just in case there's a bit of vibration. This is going into the engine compartment of a boat, and in case there's a bit of vibration, that'll stop the aluminium of the cells contacting. I haven't put on the outside because the wood is fairly non-conductive, so we don't expect a problem. In any case, if they are actually rubbing so that stuff comes off, then there's too much vibration, there's a problem anyway. So this is the yellow thing here is just to stop sort of fireworks. So that should do the trick. So next step, I am going to be looking at what I can mount these heaters on. So each of these are 10 watts, a total of 30 watts. And I don't really want to just leave them dangling like this because they get pretty hot, and I'd rather have something that is suspended off this thread bar so that it's sort of hanging in the air, so to speak, like that. And that should warm everything up.
Okay, next up is to start actually assembling this battery and getting everything back together. So just pre-warming the aluminium flat bar that we're using as a heatsink for these heating pads. They'd been in the workshop and were pretty cold, so we're just heating them up a little bit so the adhesive stuck on them nicely. Then cable tied them onto the thread bar and obviously cut the cable ties so that's nice and neat, and then started to wire up the connection on these. Initially it was just a temporary connection just so we could test them, and then we started the process of putting the bottom onto the battery. Obviously, as you can see, we've put the battery on its side, which is fine to do. These cells, you can actually store them on their side, just you should not put them upside down, but to put them on their side during the build process like this is fine. It's very important when you are putting a side or a top or bottom onto your case that you're very careful that you get your screw holes straight, and that you don't go off to one side and then pierce your cells. That's very, very critical and very, very important. So we've done this quite a lot, so we're pretty well practiced, but it's something that you need to be very careful of if you're doing this for the first time. We tend to put quite a lot of screws on the bottom. Obviously, it's holding a fair amount of weight, so all of the cells together is probably around 50 kilos. So we probably put a screw every probably 10 centimeters, every 100 mils or thereabouts. Next up was to start getting the two planks that we put across the cells that hold the BMS and all the other electrical things. So as I mentioned previously, the nice thing about building the sides like this is that you get that shelf that you can then attach a couple of pieces of wood that you can then put your BMS on.
About to start assembling everything, and we have our heating pads. So there are 10 watts each. There are 3 of them, so 30 watts of heating. So about 3 amps will be used, 2.5, 3 amps will be used for heating. I've had to extend the heating wires, just temporarily hanging loose. They're hanging off the thread bars with cable ties. This is aluminium flat bar, so it works out quite well as a heat sink. Have the bus bars just thrown on loosely. This is where the BMS will be going. I have terminated all of the balance leads. They are ready to go. So there are 10 terminations altogether, 8 cells plus the final live, and then of course the neutral. This is probably where the 24 to 12 adapter will go. So the heating pads are 12 volts, so need to cut that voltage down. And yep, everything is ready to go. The bottom is on, the sides are on and tightened, and yep, ready to assemble all the balance leads and tighten the bus bars down.
Next up is to start putting the balance leads onto your cells. So this is pretty straightforward. You have if it's an 8S configuration, you have actually 9 red cables and 1 black cable. So these JK BMSs are slightly different to some of the other BMSs out there, like Daly, for example, whereby it uses the last red cable to determine how many cells are in your battery configuration. And that's because the BMS that we're using here can be used for either 4S or 8S configuration. So it's quite adaptable. It's quite a good BMS in that regard. So we loosely attach all of the balance leads onto the terminals on the cells in the correct positions, and then we then go through and actually torque everything up. So our supplier of these EVE 304 amp hour cells has advised that we can torque them up to 8 Newton meters, and so these are laser welded terminal studs, and so that's what we torque it up to. We usually will put everything down, check everything, tighten it all up, torque it up, and then we'll usually just double check everything, go back over all of the bolts, all of the nuts on the terminals, and just double check again a second time that they are torqued correctly, because often this is an area that mistakes are made. If you leave one of the terminals that's not torqued correctly, that can be a real point of pain in terms of trying to debug things and figure things out, and also it can be an area of heat buildup if you don't torque correctly. We also torque the bolts on the JK BMS as well. I believe we torque that to 8 Newton meters as well, just to make sure that we don't have any heat buildup on that either. Once that's done, we can connect everything up and turn it on.
Progress so far. I've attached the 24 to 12 converter. So the reason for that obviously is that this is a 24 volt battery and these heating elements are 12 volts. So we're coming through from this cable will go outside so that the customer can attach it at the other side of the shunt, the smart shunt, so that he can count the coulombs used by this. So we're not going to take this straight to the BMS or anything. These two will be attached to the heating elements now. Have the wires ready. Need to mount the 2 temperature probes in a logical place. And then the next step will be to mount this little chappy, which is the thermostatic relay, or temperature controlled relay, with a nice little probe at the bottom that I'll mount somewhere.
And then it's the final bits and pieces here. So putting the temperature probes in the right place, taping them down so that they stay where we want them, and just tidying up the wiring, putting cable ties in, things like that. You may notice that we've got a couple of I forget what you call them, those white connectors to join cables together. So some people will probably have something to say about that, but that's intentional. With this battery build, we decided to put those in just for the heating pads, so that if the customer has any issues, if a heating pad goes or something like that and he needs to replace one, then it's easy for him to be able to debug and disconnect one, test it, things like that. So that was intentional. It's not just a case of like we don't know what we're doing. We used those intentionally so that he had the opportunity to be able to debug it and do that sort of stuff. Made sure everything was mounted correctly inside there, and then we start the process of putting the lid on. So we have a couple of holes where the main positive and negative cables go through the lid. The customer specifically asked for the bus bars to be mounted on the lid of this battery. We've put them all over. Sometimes we put them on the side, sometimes on the lid, sometimes they're in a recessed lid, so that there's a bit of protection from something landing on the top of the battery and then shorting the terminals, that sort of thing. So yeah, we're pretty flexible with the way these goes, and usually you're really not putting a lot of distance between your BMS and your main positive terminal and your bus bars. So in terms of the amount of current you can carry, it does make a huge difference in that regard. So this is fairly straightforward. Just drill it out and mount the lid on the top, and then we put the bus bars in place. So yeah, pretty straightforward as before. We were just careful to drill straight. Obviously this is a little bit tricky and requires a bit of skill and experience, because these are fairly thin bits of ply at this point. So it's critical to drill a pilot hole so you don't split your bottom piece there. So yeah, then we position the bus bars where we want them, mount those using the correct screws so that you don't have them sticking out the bottom, and then put the cables and the lugs onto the actual bus bar bolts and tighten those down. These we usually just tighten by hand. Pretty confident with how tight they need to be. We then passed up the black cable for the heating pads so that the customer can connect that to the correct side of his smart shunt so that he can count the usage on his battery accurately. Obviously, if we wired this directly to the BMS, then it would not give him a correct reading of the capacity of his battery and what was remaining in it, and also what his usage is. So that's obviously something that's quite important to know. So we wired it out so you can connect that where it needs to go. Then put the one side on. We're leaving the side that you can see there with the thermostatic relay open. We're marking where they're going to go and drilling the holes out, but not actually going to close this until we actually do a handover with the customer and take them through things so that we can see what is what inside there.
Here is the completed battery. The side is just left loose so I can show the customer. Able to control the relay there. not bad looking. I've left this lead on the top so that he can run it to the other side of his shunt to count the coulombs used by the heating system. This is firmly attached. Yeah, everything looking good, ready to go.